Hi and hello to everyone. In this video, we are going to see about the impulse signal. It's impulse signal in both continuous time domain and discrete time domain. That is, continuous time is CT, discrete time represented as DT, discrete time domain. We'll see the properties of the impulse signal in both the domains, and we will be giving an introduction to the impulse response. It's very important. Using impulse response only, we can do the convolution operation. Okay, we'll give an introduction. In the next video, we'll be seeing about the details how to do convolution operation. Welcome to the lecture. First, let's start with the impulse signal in continuous time domain. I represent the impulse signal as delta of t. Okay, t is a continuous variable. The t represents time. So this is an impulse signal in continuous time domain. At time 0, the amplitude is going to be infinite. Okay, so I cannot draw infinite. That is why I mark a arrow symbol. This blue color line will have a arrow at the top. That's why that indicates that it's going to infinite. So delta of t is equal to infinite when the time is equal to 0, and it is 0 when the time is not equal to 0. If you look at this, at time 0, what is amplitude? It is infinite. At time 0, the amplitude is infinite. At the negative time and the positive time, that is time not equal to 0, it is 0. So this is the definition of impulse signal in continuous time domain. And look at some properties. The area under the impulse is 1, right? What is the area? Area is nothing but integration of the impulse signal. So if I integrate the impulse signal over the whole time, that is from minus infinite to plus infinite, that is from minus infinite to plus infinite, I will get the area as 1. Okay, this representation is ideal, or I can say theoretical. Practically, impulse signal is represented like this. Practically, how? If you look at this, what is the width of this line? Width of the base of this triangle, rectangle, or a rectangle, yeah. It's starting from minus a by 2, ending at plus a by 2. So the difference is a by 2 minus a by 2. So the width is a. Minus a by 2 to plus a by 2, the width is a. Okay, I said that the area under the impulse is 1, right? So the height of this rectangle should be 1 by a. So what is the area? Area of the rectangle is the width. This is the width. This is the width. This is the height. Okay, so width into height. Width is a, height is 1 by a. So the area is 1. Okay. Now, can you relate the relation between the practical case and the ideal case? In the ideal case, what happens to the width? Width has become 0. This has been shrinked. Okay, a is becoming 0. So what happens to the amplitude or the height? 1 by 0 is infinite. That is why it is going to infinite. Okay, right? So the important property is area under the impulse is 1. This is how we will represent the impulse signal practically. Next, we will look at some other properties like delta of t into x of t, and we know delta of t is when it is present, impulse is present only at the time any impulse is present only at the time 0. Okay, so delta of t into x of t, it is present only at the time 0, so it becomes delta of t into x of 0. Okay, so if it is delta of t minus 1, what happens? Impulse is delayed by the 1 unit t minus 1. So inside the bracket it should be 0 because impulse is present only at the time 0. So t minus 1 should be equal to 0. T minus 1 0 means t is equal to 1. So it becomes delta of t minus 1 into x of 1. Similarly, if you observe t plus 1, t plus 1 should be 0 because impulse is present only at the time 0. For other time it is not it is 0. Okay, so impulse is present only at the time 0. So t should be t plus 1 is equal to 0. So t equal to minus 1. So I can consolidate this as delta of t minus a x of t is equal to delta of t minus 1. What is t minus a should be equal to 0 means? T should be equal to a, equal to x. So x of a. Now, integrate. integrate delta of t and x of t, right? And as I said earlier, when the impulse is integrated, it becomes 1. So integral of delta of t dt is 1. So x of 0. You can compare 2 and 3. Just multiplication means it will have only x of 0. That time t minus 1 means x of 1. T plus 1 means x of minus 1. Okay. So on integration t minus 1 x of t minus 1 means I have only x of 1. T minus 2 means I will get x of 2. So this is an important property. Delta of t minus a x of t dt. You have to observe very closely. Inside the impulse bracket, it should be equal to 0. That is, t minus a should be equal to 0. T minus a 0 means what is this meaning? T minus should be equal to 0. That is t equal to a. Okay. So in t equal to a, integral of delta of t minus a dt is 1, right? Because we are integrating from minus infinity to plus infinite. Okay. This is another property. Next, impulse signal is an even signal. What is even signal? Even signal is nothing but delta of t is equal to delta of minus t. Okay, so both the positive time and negative time, the signals will be the same. At both the same positive time and negative time, the signals will be the same. Delta of t and delta of minus t are equal. That is, impulse is an even signal. Then, then this is an important property. In this textbook, the proof is given. Okay, using e-cones, they will be proving. They have given the proof for this property. Delta of at is equal to 1 by magnitude of this a delta of t. Okay, then okay, right, we'll see. This is a unit step signal, right? What is unit step signal? Unit step signal is a signal whose amplitude is 1 for the positive time and 0 for the negative time. For the positive time it is 1, for the negative time it is 0. Okay, fine. Now what happens when I differentiate the impulse signal, sorry, step signal, unit step signal. Okay, during negative time it is 0, so differentiation is 0. During positive time it is 1. When constant is differentiated, it is still 0. What is differentiation? Differentiation is nothing but rate of change. Differentiation means rate of change. Differentiation. Differentiation means rate of change. Okay. So during the positive time, there is no change, it is constant. During negative time also it is constant. So when there is changing, it is changing only at the time 0. Only at the time 0. What is the change in amplitude? It is going from 0 to 1. So what is the change? Change is 1. So that is 1 minus 0. Change in amplitude. What is change in time? This is change in amplitude. Change in amplitude of the signal. Okay, what is the change in time? Time is 0 minus 0. There is no change in time. Okay, so it is 0 minus 0. So it is 1 by 0. We get infinite. Right? So the simple thing is, when I differentiate an unit step signal, I will get an impulse signal. That's why differentiation of unit step gives impulse delta of t. Next, what happens? The signal is unit ramp signal. What is unit ramp signal? For the negative time it is 0. For the positive time it is keep on increasing. Okay, right. So R of t equal to t for t greater than 0 and 0 for t less than 0. Right? T means, what is the meaning? At time 1 amplitude is 1. At time 2 amplitude is t 2. R of t is equal to t. 1 means 1. 2 means 2. 3 means 3. Time 4 means 4. This is how the unit ramp will look like. Okay. Now I'm going to differentiate this. What is differentiation? Rate of change. So what is the change in amplitude? I take this part. You can take any segment. I am taking this part. The amplitude changes here. It is from 1. The amplitude is going to 2. Okay. Between these two line segments, sorry, horizontal lines. Okay. So the change in amplitude is where it is ending. It is ending at 2. It is starting at time. Sorry, amplitude 1. So this is change in amplitude. Okay. Here I can write change in time. The denominator is change in time. Change in amplitude. Okay. So the numerator is change in amplitude. Change in amplitude. What is change in time here? Time is changing from 1 to 2. So the change is 2 minus 1. So this is change in time. So the answer is 1. Okay. After the segment, you can take any segment between 2 and 3, or 3 and 4, or 1 and 3, or 0 and 1. It will be always 1. So the slope of this line is always 1. Okay. So what is the meaning? When you differentiate the ramp signal, I will get 1, that is your u of t. Okay. So what is the conclusion we are making here is, it is I can say like ramp when differentiated, I will get step. Step when differentiated, I will get impulse. Similarly, the reverse order, when I integrate the impulse, I will get unit step. When I integrate the unit step, I will get ramp. Okay, so this is very important relation between impulse with other signal. If impulse signal is given, if the impulse signal is given, what I have to do? 2 times if I integrate, I will get ramp. Similarly, if ramp is given, 2 times if I differentiate, I will get impulse. Okay. After ramp, people ask me, I can say we will go to, if I integrate the ramp signal, I will get parabola. What is parabola? It will be like this, no? Okay, this is a parabola. Okay. Those things you can learn by yourself, right? Elementary things in your custom max is there. Okay, now we'll solve few problems. Okay, let's see the first problem. Cos t delta of t minus pi. Okay, evaluate this. This is the question, right? We know that how to evaluate, because delta of t is valid only at 0 inside the bracket. Inside the bracket, it should be 0. So I can make it like this should be equal to 0. That is t minus pi is equal to 0. So t equal to pi. So cos pi delta of t minus pi. Okay, t minus pi. So cos pi is minus 1, delta of t minus pi minus delta of t minus pi. Okay, so the answer is minus delta of t minus pi. Okay, take another problem. Integral of delta of minus 3t dt. Integration limit is from minus 4 to 4. Okay, right? And we know a property. What is the property? Delta of at is nothing but 1 by magnitude of a delta of t. Similarly, I can write this as 1 by magnitude of minus 3 is 3 delta of t dt. Okay, this term, this integration is 1. So the answer is 1 by 3. Answer is 1 by 3. Okay, take another problem. What is the answer? Right? They are asking the integration between the limit minus 3 and minus 2. The answer is 0, because people immediately think area under the impulse is 1. Of course the area is 1, but where the impulse signal, it is at the time 0, it is going to infinite. Okay, and where is the integration limits? The time is between minus 3 and minus 2, minus 3 and minus 2, in between these two areas, right? Okay, so I am not at all going to take the impulse signal. It is not at all covering the impulse signal. So the answer is 0. Between the time minus 3 and minus 2 is 0. Suppose the same problem, if I'm modifying the limit from minus 3 to plus 3, the answer is 1. Why? Because impulse is present only at the time 0 and the limit is between minus 3 to plus 3. Minus 3 to plus 3. Okay, so thereby what I'm also covering the impulse signal. Okay, so the answer is area under the impulse is now 1. So it should be from negative time to some positive time, then it is okay. The answer is 1. If it is between 2 negative time, or else if it is between if we look at the another case like if it is between 2 and 3, delta of t dt, the answer is still 0, because 2 and 3 means between 2 and 3, impulse is only here. Okay, 2 and 3, we are not at all covering the impulse. Okay, so the answer is 0, right? Take final problem. Sixth problem, you can say. Integral of sin t delta of 2t minus pi dt. Limit is from minus infinity to plus infinity. Okay, so first thing I have to apply the property. So what is delta of 2t minus pi? Sorry, delta of 2t minus pi equal to, I can write this as delta of 2. I can take 2 commonly outside, it becomes 2 into t minus pi by 2. Okay, now delta of at format now, so I can write this as 1 by 2 delta of t minus pi by 2. Now put it in the question. Sin t 1 by 2, I'm bringing outside of the integration, delta of t minus pi by 2 dt. Okay, now observe that when this integral of delta of t becomes 1, only a t should be equal to pi by 2. If you observe this, this should be equal to 0, that is t minus pi by 2 should be equal to 0. T equal to pi by 2. So 1 by 2 sine pi by 2. Sine pi by 2 is 1 and the answer is 1 by 2. Okay, right? Next we move into the discrete time impulse signal. That is a discrete time domain. It is represented by this, right? Only at the time 0 it is 1. For the negative time and positive time, I can write the negative time for your case like minus 1, minus 2, minus 3, 1, 2, 3. For all the negative time and all the positive time it is 0. Only at time 0 it is 1. So delta of n is equal to 1 for n equal to 0. Delta of n is equal to 0 for n not equal to 0. Important difference between continuous time and discrete time domain is, here at t equal to 0, there it is infinite. Here n equal to 0, it is 1. Okay, now similar to that case, x of n in delta of n is equal to x of 0, right? Because when this is 1, when the impulse is 1 in discrete time domain, only at n equal to 0, so x of 0. See, observe that x of n delta of n plus 1, inside the bracket of del it should be equal to 0. So n plus 1 is equal to 0 means n is equal to minus 1, so x of minus 1. Okay, so I can write this as x of n delta of n minus a equal to x of a. This I can explain this using this example. Okay, right. Let me take an x of n 1947. This arrow indicates this is the point n equal to 0. I can draw this graphically, right? At n equal to 0, what is amplitude? 1. At n equal to 1, what is amplitude? 4. At n equal to 2, the amplitude is 7. At n equal to minus 1, so this side is right side positive, left side is n is negative. So this is 0 means this n is equal to minus 1. At n equal to minus 1, the amplitude is 1. Remember, in discrete time domain, n should be always integer. That is, it can take the value minus 2, minus 1, 0, 1, 2, 3. There cannot be any values like 1.5 like that. Okay. So these both are same. This is graphical representation. This is using some expression, mathematical expression. Okay. Right. Now, if I multiply, what I'm doing here, x of n multiplied with delta of n. What is x of n? What is delta of n? I have already drawn delta of n. I can repeat it here. I can draw here, the right side. This is my delta of n. At 0, it is 1. Okay, what I am doing, I am multiplying x of n with delta of n. Okay, so this is my delta of n, this is my x of n. If I multiply, what happens? Only at 0 it is 1, remaining time it is not there. So 1 into 9, the answer is 9. Okay, so x of n in delta of n minus 1, this is my n minus 1, because impulse is delayed. Okay, this is delta of n. Delta of n minus 1 means one step it is delayed. Now if you multiply this with the x of n, what I will get? I will get only 4. At time 1 it is 1 here. At time 1 it is 1 here. At time 1 it is 4 here. So 1 into 4, 4. Similarly, delta of n minus 2. N minus 2 means it is 2 units delayed. It is 2 units delay. Okay, at n amplitude is 1 here. At 2 it is 7 here. So the answer is 1 into 7, 7. N minus 3. What happens? N minus 3 means 0, 1, 2, 3. It is delayed by 3. At 3 it is 1. So this is my delta of n minus 3. Okay, if I multiply this, at 3 it is 1. Here there is no signal at 3. So it is 0. Okay, similarly delta of n plus 1. I have advanced by 1. So instead of 0, the signal is moved to minus 1. So if I multiply at minus 1 it is 1. At minus 1 here it is 1. So 1 into 1 is 1. Okay, this is how we will work with the discrete time impulse signal. Working with discrete time impulse signal is very easy. Okay, just you have to multiply. We have to shift the impulse signal and you have to multiply with the original signal. And we will see the relation between discrete time unit step signal. Unit step in discrete time in T. Okay, so this is how 0, 1, 2, 3, 4. This is my u of n. That is a unit step in discrete time signal. That is u of n equal to 1 when n is equal to 0, 1, 2, 3, 4. Positive integer values. 0 for minus 1, minus 2, minus 3, negative integer values. Okay, this is my u of n. Can you try what is u of n minus 1? U of n minus 1. N minus 1 means it is delayed. Okay, so instead of 0, the signal will start only at 1. Okay, this is my u of n minus 1. The amplitude is 1. Both the cases, right? Okay. Unit step and unit step u of n minus 1. So can you find what is the difference between u of n and u of n minus 1? What is the difference? You have to subtract u of n minus 1, you have to subtract from u of n, right? So at 0 is 1 minus 0. So we will have a signal like this. At 0 we will have 1. For other time, here it is 1, here it is 1. So 1 minus 1, 0. At 2 it is 1, at 2 here also 1, 0. 3, 1. Okay. So for all the time it is 0. So this is nothing but your unit impulse signal in discrete time domain. Okay, remember in continuous time domain we will use the term differentiation. Here we are using the term difference. Okay, there we will have Integration we will say in discrete time domain as summation. Okay, so difference between u of n and u of n minus 1 gives unit impulse signal delta of n. Next, very important thing, we'll look at what is impulse response, right? And we know what is in LTA system. LTA stands for linear time invariant system. Any system we know will have an input and output. Here I have taken both the cases in continuous time domain and discrete time domain. Okay, x is the input, y is the output. Continuous time I use t, discrete time I will use n. If I give the input as impulse delta of t, the output h of t or h of n is called impulse response. So what is impulse response? Impulse response, the response of the system for impulse input. Okay, so I will take a system, I will give impulse as input, and the output I am getting is called impulse response. Okay, so what is impulse response? I give the impulse input, the response or the output I am getting is called impulse response. Why impulse response is very important? Because it characterizes the system, because it defines the system, how the system is working is determined by the impulse response. Okay, the important property of impulse response is when we know the impulse response, that is, once we characterize the system by giving the impulse, by studying the output, that is understanding the impulse response, that is h of t or h of n of the system, we can find the output y of t or y of n for any input x of t or x of n using convolution operation. This is very, very important. Convolution operation, right? So first thing, if we have a system, what you have to find? You have to find the impulse response. How will you find the impulse response? I will give the input as impulse, output is called impulse response. Discrete time the input is delta of n, output is called impulse response h of n. Okay, once you know this h of t and h of n, sir, I know this h of t and h of n, then what I can do, using this you can find the output for any input. Okay, that is, we can find the output for any input, but what you have to know, we have to know the impulse response. Okay, so impulse response is very, very important. As I said earlier, the relation between impulse signal, step signal and ramp signal is true for even impulse response and step response. Sir, I have the impulse response. What is impulse response? I said impulse response is h of t. So if you need step response, I can say step response is s of t. What I have to do? Just you integrate. Okay, these things will be I will be explaining in the next videos clearly. We'll be working on problems for convolution operation for both the discrete time domain and continuous time domain, and I will be explaining what is the relation between the impulse response and step response. Okay, I hope you will learn something useful from this video. Thanks for listening. Do subscribe the channel. Any doubts, please ask in the comment section. Jai Hind.